Spacecraft reveal the birth and evolution of an extreme solar superstorm. For the first time, scientists have been able to track the life cycle of an exceptionally powerful solar active region almost continuously for 3 months, revealing in unprecedented detail how the sun builds the conditions for extreme space weather. By combining observations from 2 complementary spacecraft, one near Earth and another orbiting the sun, researchers followed a massive magnetic structure as it emerged, intensified, and ultimately produced the strongest geomagnetic storms recorded since 2003. If you like my content and want to listen more interesting science stories like this, then subscribe my channel. And don't forget to like and share this video with your friends and colleagues. Seeing the sun beyond Earth's view. Because the sun rotates roughly once every 28 days, any single region on its surface remains visible from Earth for only about 2 weeks before rotating out of sight. For decades, this limitation has left major gaps in scientists' ability to observe how active regions evolve over time. That barrier has now been overcome with the European Space Agency's Solar Orbiter, launched in 2020. Unlike Earth-based observatories, Solar Orbiter travels along a wide inclined orbit, completing 1 revolution around the Sun every 6 months. This trajectory allows it to image regions of the solar surface that are normally hidden from Earth, including the Sun's far side. This mission fundamentally changes our perspective, explains solar physicist Ioannis Kontogiannis of EETH Zurich and the Istituto Ricerca Solari Aldo A. Celle Daco. DD. We can now follow solar activity even when it disappears from Earth's view. An exceptionally dangerous solar region emerges between April and July 2024. Solar Orbiter observed one of the most extreme solar active regions seen in more than 2 decades. Designated NOAA 13664, the region first emerged on the Sun's far side in mid-April 2024. When it rotated into Earth's view in May, it immediately revealed its extraordinary intensity. The region went on to generate the most powerful geomagnetic storms to strike Earth since 2003, producing auroras visible at unusually low latitudes. The aurora borealis reached as far south as Switzerland, notes Louise Hara, professor at ETH Zurich and director of the Davos Physical Meteorological Observatory. 2 spacecraft, 1 continuous timeline. To reconstruct the full evolution of NOAA 13664, Hara Kontogiannis and their international team combined data from Solar Orbiter with observations from NASA's Solar Dynamics Observatory, which continuously monitors the Sun from the Earth sunlight. This dual spacecraft approach allowed the researchers to track the active region almost without interruption for 94 days. An unprecedented achievement in solar physics. This is the longest continuous observational record ever produced for a single solar active region, says Kontogiannis. But it marks a major milestone in our ability to study solar magnetism. Magnetic fields as the engine of solar storms. Solar active regions are shaped by intense and highly complex magnetic fields. These structures form when magnetized plasma rises from the Sun's interior and pierces its surface. As the magnetic field lines twist, stretch, and tangle, they store enormous amounts of energy. When this magnetic stress is suddenly released, the result can be a solar flare, an intense burst of electromagnetic radiation, or a coronal mass ejection, which hurls billions of tons of plasma into space. Such events can propagate through the solar system, driving powerful space weather at Earth. By observing NOAA 13664 across multiple rotations, scientists watched its magnetic configuration grow progressively more intricate. This gradual buildup culminated in the most powerful solar flare of the past 20 years, which erupted on the Sun's far side on May 20, 2020. Consequences for technology on Earth. While solar storms are visually striking, their technological consequences can be severe. Strong geomagnetic activity can disrupt satellite operations, interfere with radio and navigation signals, damage power grids, and increase radiation exposure for aircraft crews. A notable example occurred in February 2022, when elevated solar activity caused 38 of 49 newly launched Starlink satellites to re-enter Earth's atmosphere prematurely. The effects of NOAA 13,664 were felt even closer to home. Railway signaling systems can be disturbed, sometimes switching incorrectly between red and green, Hara explains. That's genuinely alarming. Digital agriculture also suffered during the May 2024 storms. Disruptions to satellite, drone, and sensor signals forced farmers to halt operations, leading to crop losses and measurable economic damage. Toward better space weather forecasting. Understanding how extreme solar regions form and evolve is essential for improving space weather forecasts. Continuous observations of NOAA 13,664 have provided valuable clues linking magnetic complexity to eruptive potential. When we observe an active region with an exceptionally complex magnetic field, we know a large amount of energy is stored and must eventually be released, says Hara. However, predicting exactly when and how that energy will be unleashed remains a major challenge. Scientists still cannot reliably determine whether a region will produce a single massive eruption or a series of smaller events, nor can they accurately forecast the timing of these out. The next step. Vigil. To close this gap, ESA is developing a new mission called Vigil, dedicated entirely to space weather monitoring. Scheduled for launch in 2031, Vigil will provide continuous side-on views of the Sun, offering earlier warnings of Earth-directed solar storm. The Sun is the only star that directly affects our daily lives, Contagianis emphasizes. If we want to protect our technology and infrastructure, we must understand how this star works. The unprecedented observations of NOAA 13,664 mark a turning point, bringing scientists closer than ever to decoding how the Sun builds, stores, and releases the energy that drives the most extreme space